which is why I've become a great devotee of this. And this book, which was early in 1999, has been followed. This one's free on the web. It's called Illuminating the Path. It's a research agenda. And this one probably is, the place to go. It's a 170-page book. It's from the European Union, which is trying to follow this topic, but called Solving Problems with Visual Analytics. And you see the emergence of new terminologies here as well. The shift from what usually is seen as a more technical computer science topic of information visualization to the use of the term visual analytics, which suggests a process model. That it's not just the visualization, but it's a process. And analytics is a hot topic, and so you might go and try to track down this topic. And this book, probably if you search on the name Daniel Keim, K-E-I-M, this is a free book to download as a PDF, 170-page book. So is the second one. Unfortunately, our book is not free to download, but that's how it goes. That's how publishers work. But these other two are pretty good reviews of the area, and this one, since it's more recent, is the place I'd steer you to as a good resource for what's going on. The indication that this topic has caught on is pretty clear by way of just the business world, that the small companies, often started by university, faculty, or other innovators, who got bought by the middle-sized companies, and then the middle-sized companies got bought by the bigger companies, and so it goes. And IBM has bought Cognos and Celiquest and iLog, and last year SPSS as well. So they've now created a whole suite of these different visualization tools. And our work was on something called Spotfire, an academic paper in 1994. A student named Chris Alberg formed the company in 1997 and started selling, and it took 10 years to build the company up to 200 people, at which point it was bought by the company called Tibco in California. So it was, for me, very satisfying to see an academic idea becoming a success story in the marketplace. Unfortunately, Spotfire is an expensive tool. You can get a free trial for 30 days, so you can try it out at spotfire.com. But I would say it's still the high-end successful product. Their main focus is on large companies, pharmaceutical drug discovery, Pfizer, Novartis, AstraZeneca, but then the oil and gas discovery and the financial people and production management and lots of other places have come to use it. And the features here are ones that we're going to see recurring in the other systems later. But I'm particularly proud of this. This example comes from a British researcher named Nick Thomas, and he was looking at some genomic data. And this is the rare occasion where a discovery is represented in a single slide, a single screen. Usually it takes, as I say, a process model. But Spotfire has something called a guide. Users can create an explanation, and then the users can then click on different features to highlight things. And so that's another interface creation tool. And here we're seeing 1, 2, 3 coordinated views, plus the control panel, and then the details on demand. So the data is from one of these genomic gene expression data studies. And the important point is this, which Nick Thomas discovered over here. That red spot was unexpected. Okay, red means high activity. For the RBP1 gene, was totally unexpected by his research, and that is highlighted over here, and over here. As again, this projector doesn't show it all to its elegance, but you use a control panel to filter out these double box sliders, give you the range, and when you click on any one of them, the details of that item show up over here. So this is the way we began to represent information, and that the role of the RBP1 gene is important because it triggers the development of retinol, which in turn influences embryonic development and the visual system. So that was the highlight for him, and this led to a single published paper. This is some other data, maybe more familiar to you. This is 10,000 births in Washington, D.C., and it has about 40 data fields. This is, so 10,000 rows of data and 40 columns. And the columns are things like the place of the birth and the age of the mother, the age of the father, the race of the mother, the marital status, whether it was single birth, twins, triplets, or quadruplets. And you can very quickly explore it. And I set this up very easily that the age of the mother is here. You can see the youngest mother is about 11 or 12. The oldest is about 50. The youngest father is about 12 or 13 and goes up to 65. The red dots are baby girls. The blue dots are baby boys. They're actually sized by the birth weight. And so you can pack quite a lot of information and see, and basically you can see the correlation between age of mother and age of father, but you can see the outliers, the exceptions to the rule, and you can select them as sometimes a very old father with a very young mother. That's pretty unusual, but there may be old mothers with young fathers. I mean, there's all kinds of interesting things that may stand out or catch your attention. Once you engage your mind in looking at this kind of a display, you begin to formulate those questions and begin to make insights even from the simple static display. And then the sliders will let you see, well, let's take a look at the gestation period. Do we believe that older women have shorter or longer gestation periods? Well, I just pull the slider and I can see the proportion that are left. So and there's other factors you can look at, like birth weights. Do we think the birth weight is related to the gestation period? Absolutely. And I didn't show that here, but you can see those things too. This is another kind of discovery I made that my colleagues, and this is now about 10 years old, but if you do the distribution of age of mothers, white mothers, black mothers, Asian, and American Indian, very few American Indian births in D.C., but there are a few. You can see a few of those, and a number of Asian births. And here we see the blue are the unmarried and the red are the married mothers. So in the black community, the average age is maybe about 25, whereas in the white mothers, it's more like 35. Okay? In the white community at that time, they're still largely married, whereas the black community was accepted that there might, that having children without having a father was common. Now it's become common in both communities. If you redid that, you'd find a much higher rate of white women who have children without being married. And so these kind of phenomena stand out if you train your eye to look at the data. All right. So we're not going to do much about Spotfire, but Spotfire is used in a lot of high-end applications. And here, 27 windows let us see a complicated data set, so we can explore a lot of variables and their relationships all at once. And that's kind of the direction things are going, of a higher visual space. And more we see situations like these, where this is the workspace that people have. This is the standard Bloomberg financial way of seeing data. Spatially stable layout of information, no overlapping windows, no resizing, no moving, no scrolling. Everything you want is up there. Just move your eyes, make your decision, and make the trade. So that's no longer as expensive or high-end as you think. These kind of environments are increasingly valuable, and the evidence is very strong and clear that productivity goes up dramatically with more screen space. So if you want to, tell your managers to buy you a second or third or fourth screen, because it's going to increase your productivity, and that's generally very true. A larger screen will do that as well. We've known that for a very long time. It used to be expensive to have large screens and lots of pixels, but it's less and less so. This radiology suite shows you 16 images, and by now, many of the radiologists are using a double set, so you can see 16 images of this week and 16 images of last week, so you can compare the tumor from one week to another week, not flip back and forth. Okay? And those are the kind of environments we see here, these larger spatial environments, which are very pretty, you know, they may have proved useful, but, you know, we're moving up from the 1 megapixel to the 10 megapixel display to the 100 megapixel display. And these kind of work environments for people who are making important decisions. This is a counterterrorism control center in the DC area, and you can see each analyst has a series of 4 screens, and they work, you know, in their own areas, and then there's a bunch of shared data that lets people see what's going on. So this is kind of for life-critical, mission-critical kind of things. But operating rooms are increasingly, medical operating rooms are increasingly this way. Unfortunately, in the medical case, so much of those environments are chaotic because there's so many different products and so many different contractors that each one has a different interface and a different color scale and a different layout, and that's a problem. So we're only at the early stages of consolidation of this to try to bring you know, order and standardization and common practices. It also works on small displays, and the notion, you know, on your iPhone. You know, I use this almost every day when I drive back from College Park to our house, our apartment in Bethesda, and just to see if the beltway is crowded or not. The red lines are the traffic delays. It's remarkably accurate and timely, and so this provides a beautiful visualization on a familiar map in a very quick and easy way that a glance at it tells you what to do. Simple bar charts, and again, I'm not sure what my radiologists do all his or her work on an iPhone or BlackBerry, but it can be useful in getting information across, and the increasing use of tablets and dashboards are making this a very prevalent atmosphere. The rate of uptake is gratifying to me and remarkable, let's say. So here I come to the sort of first observation, which I've hinted at already. I wrote this rather playfully in a paper which has now collected some 2,000 citations, so somebody's paying attention. That's a lot for a scientific paper. But I playfully called it information visualization mantra. And I wrote it in the paper just this way, 12 lines, with each line representing a project where we struggled for weeks or months to try to put things together and make a design. And it said, show me the overview first, whether I have a million or a billion, show me the whole thing. And then allow me to zoom in on what I want, filter out what I don't want, and then click for details on demand. And that became a kind of theme which many people appreciated, and many of the papers put this to work. Others, of course, contradict it and disagree with it and think it's wrong, and there are other ways to do it. People extend it, people make jokes about it, there are various videos that make fun of this and add other kind of things to it. But I think the attraction to it was, and the reason people liked it, because it reasserts the centrality of human decision making. It's not that some magical algorithm is going to give you the solution you need. It's that you, the user, are going to look at this overview. You are going to zoom in on what you want. You are going to filter out what you don't want. And then you will make the insight and click for details of it. So as I show you these demos and examples, just watch out for how this idea is applied and think about how it might work for you. This is in contrast, really, and the reason why it was maybe 10 or 15 years ago such a significant thing is because most tools, like, you know, SQL and other database search things, they'd be a blank screen and say, you can type any query you want. And you have no idea what query you want to type. Okay? And then if you type it, you get a result and you just don't know what to make at it. You're scrolling through 10,000 rows of data and you just, you know, it's hard to get an overview. So it's hard to see the things like the clusters and the gaps in the algorithm. So I'm going to try to illustrate that to you. Now, here's the territory that I see. There's a 50-year history of what I call scientific visualization, which includes the medical things and includes the maps. That's sort of your GIS, Geographic Information Systems. A long, positive history about that, and people have become so, you know, really wonderfully